Percent yield in reactions. So chemical reactions don't always go exactly as planned. This is the disconnect that we get between what stoichiometry tells us we should be getting out versus what we actually get out when we do experimental processes. To that end, we sometimes do percent yield calculations with experiments in order to determine essentially how efficient the reaction was in producing products. Similar to percent error, where percent error is telling us how a percentage of how far off we are from what we should be getting. Percent yield is essentially kind of doing the opposite and telling us the percentage that we got correct, like what percentage of our maximum product did we actually end up producing in the end. Percent yield is calculated by the following way. Percent yield is equal to the amount that you actually produced divided by the amount you theoretically should have produced times 100. When we say the amount actually produced, what we mean is the amount produced experimentally. And when we say the amount theoretically produced, well, this is what stoichiometry tells us. Stoichiometry is the theoretically produced amount. So by taking the amount that we experimentally produced and dividing by the amount that stoichiometry tells us we should have been able to produce and then multiplying by 100, we can find the percent yield for the experiment. So let's try an example problem. A particular reaction you are running should ideally be able to make 25.0 grams of product. After completing the reaction, you find that you have produced 18.3 grams of the product. What is your percent yield for this reaction? So to do this, we have to establish what is the theoretical amount versus what is the actual or experimental amount. The actual experimental amount, that's the amount you're going to actually produce in the process. So in this case, we find that we produced 18.3 grams of product. So that's our experimental amount, or the actual amount that we produce. Stoichiometry always refers to ideal amounts. So the 25.0 grams of product that we should have ideally been able to make, that's our stoichiometric amount. That's our ideal amount, our expected amount. So then we can calculate it by doing the following. Our percent yield is going to be the 18.3 grams that we experimentally produced divided by 25.0 grams that we should have ideally been able to produce times 100. And when you do this work out, you should get 73.2% yield. Okay, so this is fine if you're told how much you should ideally be able to produce. Again, stoichiometry is what allows us to calculate how much we should be able to produce. So let's try another problem where we actually have to use stoichiometry to find that ideal amount first. 2 moles of hydrogen gas plus 1 mole of oxygen gas react to produce 2 moles of water. You react 10.0 grams of hydrogen gas with an excess amount of oxygen. So when we say excess amount of oxygen, remember that this just means that we have more than we need for the process. We don't have to worry about it. The hydrogen gas is what's going to run out on us first, and the oxygen is something we just don't have to care about. When the reaction is completed, you recover 75.5 grams of water. Find the percent yield for the experiment. So in this case, we're given one of the two values that we need to calculate percent yield. 75.5 grams of water is the experimental amount. It's how much we actually got out of the process. What we're missing, however, is the ideal amount, that expected amount that we should get out of here, the stoichiometric amount of water that we should be able to produce. So what we can do is we can use the 10 grams of hydrogen gas to stoichiometrically calculate that. By starting off with the 10 grams of hydrogen gas, we can go through a conversion process going from grams of hydrogen gas to moles of hydrogen gas, then moles of hydrogen gas to moles of water, and then moles of water to grams of water, mass of water, in order to calculate ideally or stoichiometrically how much water we should have been able to produce from that 10 grams of hydrogen gas. The result we get is 89.2 grams of water. This is our stoichiometric amount that we should get out of this. Now we can do a percent yield calculation with 75.5 grams of water being our experimental amount and 89.2 grams of water being our stoichiometric or ideal amount. When we do out the math, we should arrive at an answer of 84.6% yield. So this is how we do a calculation for percent yield involving stoichiometry.